Okay, so now we are moving on to outcome 3. This is the only lesson in cycle 2 for outcome 3 that we do, because we actually did cover pretty much all the rules in outcome 3 in the first half of the course. So this is more of like a refresh and putting all these pieces together in the same question is what we're doing today. And then the next assessment is going to have both outcome 2, all the algebra stuff, and these exponent rules on it in kind of 2 different sections on the assessment. So the exponent rules we learned so far, multiplication. So if you have 2 exponents with the same base, and you are multiplying them, we had the rule where you can simplify that by, can't even read those numbers, add the exponents. So, oh my god, it looks like a 16 again. X to the 3 times x to the 7 is x to the power of 10. Division is the exact opposite of multiplication, and the rule works in an exact opposite way. If you have x to the 10 and you divide by x to the 3, you can simplify that by subtracting the exponents. The next rule we had was power on a power, and that is where you have one base to a power, and then that is raised to another power. And in that case, when you only see the base once and it's got 2 exponents on it, you multiply the powers. You get x to the power of 6. Okay. And then negative exponents are a thing. We worked with them a little bit in the first half. So you can, if there's a negative involved in any of these rules, you can treat it just the same. All the rules for adding and subtracting and multiplying negative numbers still work. So this should only ever come up in your last step, but what something like x to the negative 7 means, it actually means you're actually kind of dividing by x to the power of positive 7. So it kind of floats down to the denominator. Instead of x to the negative 7, you get 1 over x to the 7, which is really like dividing by x to the power of 7. So I'll kind of show that as it comes up in these. I usually do that just in the very last step when I'm simplifying. Okay. So your job then is, based on these 4 rules, I'll give you a second so that you can pause and write them all down, make sure you have them. You're supposed to look at these questions here and see if you can identify which rules need to be used and use them in the correct order so that you can simplify these expressions. So I'll let you, well, maybe we'll focus on the top 3. You can pause and then I'll work through them, and then we'll focus on the bottom 3, and then I'll work through those as well. So this one, straight up, it is just that first rule. I've got x to the 5 times x to the 4. We're multiplying these 2 things. In order to multiply powers, you end up adding their exponents. This next one, there is division in that question, but they're 2 different bases, so I can't do anything with it. I can't divide the x's and y's, so they're going to have to stay separate. What I need to look at this is, it's a power on a power. There's powers inside these brackets, and there's a power outside those brackets. And since they're both in the brackets, they both get that power of 8 put on them. So I'm going to use that rule where we multiply the exponents, and I'm going to do it to both parts. So I'm going to get x to the 32, y to the 48. 6 times 8. And that's how I have to leave it. Nothing else we can do with that one. This next one looks exactly the same, but there's regular numbers involved. So, same thing happens with the m's and the p's. I'm going to multiply by the power outside. Multiply their powers by the power outside. And then the regular numbers, this is kind of something I'm going to say all the time, you don't need a special rule for regular numbers. That is 4 to the power of 3, and that is 7 to the power of 3. It's just a regular number. It gets that power just like regular. And then you can pull out your calculator and do 4 to the power of 3 and get 64. And you can get 7 to the power of 3, which I believe is 343. I'm going off memory here, so you can punch that into your calculator and see if you get something different. Is that too big? That's way too big. No, that's 21 times. Yeah, that's it. I said I was going off memory, but I'm pretty sure that's it. So there you have it. That's how I would leave that one. The other way to think of those regular numbers is inside the brackets. This is 4 to the power of 1. Multiply the powers 1 times 3, 4 to the power of 3. So it is the same rule that we're using with the m's and the p's as well. Okay. All right, so I will get D, E, and F up on the screen. See if you can pause the video and work through those ones, and then unpause and see what I did. Okay, for this one, 2 ways to go about it. You can either do power on a power first and multiply them both by 3, since they're both in these kind of square brackets. That power of 3 goes on both of them, but I would probably do the inside of that bracket first. N to the 5 times n to the 6 is n to the 11. And then take that and raise that to the power of 3 and get n to the 33. I would do E the same way, so I'd work inside the brackets first. X to the 7 divided by x to the 5. That's the subtract the powers rule. You get x to the 2. Y to the 16 over y to the 20 is y to the negative 4, because you're doing 16 take away 20. And then I have that all to the power of 4. Multiply the powers here, because you've got 2 powers. You've got a power on the inside and power on the outside. So that's the power on a power. Multiply the power rule, and you get that x to the 8, y to the negative 16. I'm going to say it's totally fine to leave your answer like that for now. When you get into later grades, we're going to want you to do this next step. But what that really means, it's x to the 8, and since the y has a negative power, we're really dividing by y to the positive 16. So instead of multiplying by y to the negative 16, you're actually dividing by y to the positive 16. Okay, this last one here, I'm going to keep on with the same way I've been doing them. So I'm going to work the inside of the brackets first. So out front, we have a 12 and a 4. Those are regular numbers. I don't need a special rule. This is a division question. We're doing 12 divided by 4, and we get 3. It's not 12 minus 4 to get 8. It's 12 divided by 4. They're regular numbers. You divide them like regular. Where you end up subtracting is something like the next part. X to the 12 divided by x to the 20. Well, those are powers. I need a rule to be able to divide those, and the rule is you subtract them. So I am dividing. The rule is you happen to subtract the exponents. So I get x to the negative 8 there, and y to the positive 6 next. Okay. And then I'm going to bring that power of 2 inside now. It's going to turn into 3 to the power of 2, x to the negative 16, y to the power of 12. 3 to the power of 2 is 9. The y has a positive exponent. It stays up top. The x has a negative exponent. You can float that down to the bottom. So that would be my fully simplified version there. Okay. So we're going to look at these instructions here. I want you to get used to these instructions. It says simplify first. So we're going to use all our rules. And then we're going to evaluate for x equals 2, y equals negative 1. So it gives us some values to plug in, but we're not going to plug in those values until we've simplified first. So I look at this. I've got 3 different brackets. Some of those brackets have powers on them, so I have to deal with that first. That's sort of bed mass coming into play. I've got to do the exponents first, and the most outer exponents is this 3 and this 2 I'm going to deal with first. So that's going to turn into 6 to the power of 3, x to the power of 3, y to the power of 9, because again, this x has a power of 1 on the inside. 1 times 3 is 3. So there's that first bracket. The second bracket doesn't have another power on it, so I'm just going to leave it like that. And then the bottom is 3 to the power of 2, x to the power of 10, y to the power of 6 when I bring that power of 2 inside that bracket. Okay, and so we're going to pull out our calculator and do 6 to the power of 3 and get 216 for that first bracket there. I just double checked, 343 is 7 to the power of 3 earlier, now that I actually have my calculator out. X to the power of 3, y to the power of 9. Next set of brackets, 4, x to the 8y. And then on the bottom there, 3 to the power of 2 is 9. X to the 10, y to the 6. So I'm just kind of rewriting those ones after. So I'm just calculating what those numbers are. Now, I'm going to finish off the top. The top is multiplication. So we're going to start with multiplication of the numbers. And again, they're just regular numbers. I don't need a rule to be able to multiply 216 by 4. I'm going to multiply those numbers first. So 200 times 4 is 800. 16 times 4 is 40 and 24, 64. So that's going to be 864. There we go. X to the power of 11, I'm going to add those powers. Y to the power of 10. And my 10s always look like a 16 on the screen. Okay. And then the bottom is 9. X to the 10, y to the 6. And we're going to start dividing now. Y to the 10 divided by y to the 6 is y to the 4. X to the 11 divided by x to the 10 is x to the power of 1, or just x. 864 divided by 9 is 100 minus 6 is 94. No, 96? It's 96. I'm going to double check that one with my calculator. It's 96, but I'm going to double check it. 96. Nailed it. Okay, and that's as simplified as we can get. So we've done the first instruction, which is simplify first. And now we're going to follow the second instruction, which is evaluate when x is 2 and y is -1. So I'm going to put a full stop there. Maybe I'll go way over here to do this next part. It is a completely separate thing. So we just have to understand what this means. So remember, when there's no symbol between things, it means we're multiplying. So we have to do 96 times x times y to the power of 4. So 96 times x, which is 2, times -1 to the power of 4. So BEDMAS, you got to start with the exponents. So 96 times 2, -1 to the power of 4 is +1. If you punch that into your calculator and get a negative, it means you need to put the negatives around the brackets. You got to use your bracket buttons on the calculator. You got to put brackets around the -1 before you punch it in. You should get +1 on your screen. That's because -1 times -1 times -1 times -1. Well, two negatives make a positive, so you get +1 times -1 times -1, and then you get -1 times -1, and then you get +1 so these two make a negative, but then those two make a positive. So a negative to an even power, how it works out, if you've got an even amount of negatives to an even power, you end up with an even number of negatives. And when you have an even number, I can speak. When you have an even number of negatives, they kind of match up and make positives. So if you have an even power, you'll end up with a positive answer. If you have an odd power, if it was -1 to the power of 5, you'd have one that's odd one out that doesn't match up to make a positive, so your answer would stay negative. Whew, that was a lot of talking. Are you still watching? I hope so. And then we're just going to multiply 96 times 2 times 1, so that's going to be 192 as our final answer. All right, so you stuck through it. That's our video lesson for today. So there's some practice here that's a mixy-matchy of all the different rules. I don't think there's anything too crazy different than what we did in these. So see if you can work through some of those, see if you can use those rules. And again, these are getting into the higher level star questions for the power stuff. So the rules one at a time here, those would be a lower 2-star, 3-star level. And then once I start mixing in all the rules, we're getting into that 4- and 5-star level. Okay, so do those practice, and I will post answers to those so that you can check your work and get in touch with me if you need any help.